Hi, I'm Wally, and for this lab, we have done I have done the part of the part one and part two. So for part one, I have created the things, vehicle 0 to vehicle 4, which is the corresponding to the five vehicles we got for the data. And we create a policy and assign the users in the AWM Identity Center. We set the groups and set it, we have create a group of the IoT project, and we assign the users uh, to the corresponding jobs they have done. So for the coding part, we have the LAB4 emulator client coding. So for this part, I have changed it to modify the client the data path to denote all the vehicle fires, and also modify the certificate for each vehicle. You start here for each vehicle. And then for this part, for the listening part, we have listened not only the vehicle data, but also subscribe to the topic of the uh, result, which is the related to the part two about the max CO2 data. And also the publishing part, we're not only sending the vehicle data we get from the CSV files, but also the the device ID. We also send that in the file so that in computation you could send us back the related result. As you can see, we change the input into by the data of the CSV. Okay, so this is for the part one. And for part two, mainly related to the process emission part. So in this part, we create the function of the lambda handler, and I modify uh, the way to get the data, and I also got the user ID. And after calculating the max CO2 emission, we send it back to the users based on its user ID. Yeah. So in this way, after publish the result, only the device listening to this portal will get the result, but not the others. Yeah. And as you can see, it's working now. And I decide to send more information, I can send it. And the MongoDB we can oh no the MongoDB the AM we can find it. You can find it from the IoT core. That's if we subscribe to uh, vehicle data and then do the sensing again, and then you will get all the data of the from the work. And if we send it back, let's see, if we send the result back, and we said max, let's see, max CO2 equals 2.63, and we publish back. We will get the result here. That's 2.33. And only client 3 is receiving this information. And that's all. Thank you so much.
So these are the different plots on Sage. So the first plot you can see is so as you can see, it's a bit of the configurations as well as the time. You also see the different number of the different types of gases that are produced. It's particularly using the correlation of the different types of emissions. So if we count, let's say you can see as well as the correlation, but this is the ones on the x-axis. Further down, you can see the spatial distribution of CO emissions, and the white bar is actually telling you the CO emissions, as well as the X coordinate. And the color actually tells you the intensity. Most of which you can see the distribution of the speed across different things. So we complete as well as the fashion units. It's active on this. That appears to be slightly So first, what we did is we ran the sumo dash C file, and which helped us to generate the FCD file, the Q file, as well as the sumo network file, as you can see here. Once all these three files are generated, what we've done is we also ran the parser.py, and the parser.py did generate two files, which is data.txt, at the same time label.txt, right? So what we did is we then ran the Jupyter notebook uh, with by feeding in both the data.txt file as well as the label.txt file, and we ran the entire notebook, which is essentially a neural network, and we ran for 20 epochs, post which we got the loss as well as the accuracy curves. Um, so this is about the appendix part two.